So after chapter 2, the next chapter is on functional dependencies. Right. This is probably the most technical part for, not technical coding part, but technical thinking part, as far as database systems is concerned, and that is functional dependencies. Right. Now I know that you know what functional dependencies are, except that maybe you have not thought of the functional dependency. Right. You use it every day, but you don't actually. You don't call it functional dependency. But if you are, I should say, a logical thinking, rational being, somewhere in your mechanism, there is this A implies B thing going, which you saw maybe in discrete math. If not even in discrete math, you've seen it in some form of programming. And when you see this, do that. That concept is really functional dependency. So it is written as A implies B, the same way you had it in, so one thing implies, say functionally determines B. Right? So we say that something determines another thing. That means that whenever it occurs, we expect that it should go together. Right? So I'll give an example. It's like this little table here. So you realize that there are many different columns, right? So there is an item column, a price column, supplier column, country, and CEO. Is it possible that, so if someone says, every time I have rice, I get 2. If that rule holds, then it means that what? The item determines what? The price. So if you look at any table, usually that's the question you should be asking yourself. What columns determine what other columns? Is everyone okay with that point? For any table. So aside from, so I found one out. I said item determines price. So if someone says something like that, you can test it. To test it means that what? You can go through the data and see if there are any violations. So in this case, bread is 1.5. Always bread 1.5. Milk is also 1.2. So as far as we are concerned, item is determining price. Right? What about between item and supplier? Is there any rule there? Right? Because if you pick rice, sometimes it goes to Southgate, and sometimes bread, the one that is violating rice is going to Southgate sometimes. Other times it's going to Annalisa. Right? And so you also have to ask the direction. What about the other way? Does supply determine the item? No, it doesn't. Okay, what about this one? Does price determine the item? Whenever I have 2, does it always go to rice? Whenever I have 1.5, does it always? So it means that, or there's a violation. Right. So it means as far as the data is concerned, it goes that item determines price, and that price also determines item. So sometimes you can have these, and those are discussions that, as data scientists, you have to ask yourself. Given any set of data, which things determine which other things? Right. So why do you think it's good to know these rules? Or to determine what these rules are?
I think maybe to make it easy to manage the database, so that they say whenever I see 2, I don't need to go to the item column to know that it's rice. Or maybe whenever I see rice, I don't need to go to the price to know that it's soup.
So that's a very good point. The management of the information. When you see one, you know that it should go with the other. Someone has the hand up. Okay, so if you know what determines something else, it can also help you with your relationships, right? Already, I know that because you were picking your own projects, you already know how things are related. But if you are working on, and sometimes you can get a database table where you have no idea, you have no idea, but let's say you go and work for Ministry of Energy. There'll be certain columns that maybe you don't understand what they mean, right? Or there are certain ID numbers, you don't understand what they mean. But if you start to check the data, you can start to see some patterns, right? And as someone said, it will help you manage the data. Because if you see that, every time I see this customer ID, it goes with this, then you know that that's a rule, that's sort of a rule that's holding. So if any data is coming in, you can use that to check against. And if any data is already in there, and you ask the person, is it true that the price is determined by the item? That's now a question you can now ask the person. The person will say, yes it does, no it doesn't. If he says yes, then you can add it and say, this is something else that my application can be checking on. So it's good to know these functional dependencies. It's similar to what you have in discrete mathematics. What about between supplier and country? Supplier to country, no, and the other way it doesn't, right? Because from supplier, if you pick someone like Annalisa, sometimes it goes to Germany, sometimes it goes to Denmark. So from the supplier, you cannot determine the country. From the country, you also can't determine the supplier. Because what? You have China going to Southgate and China going to Sheng Limited. What about country to CEO? Okay, so why no? If you say no, then I ask you why no. Alright, so you have China goes to Chen, China goes to Ahmed. That's violating country determining CEO. What about the other way? The CEO determine the country. Right. So that's another violation right there. So you're having that Chen, well, Schultz is sometimes Germany, Schultz is Denmark. Right. So supplier, let's see, from Southgate you always go here from Schultz. Well, so yes, Annalisa always goes to Schultz, and Southgate goes to Chen. Sheng Limited goes to Ahmed. Ghana House goes to Kwachi. So yes, supplier does determine the CEO. So if you know the supplier, you should be able to determine the CEO. Some people are catching on to this. See, it's very, very easy. Databases is one of, as I said, one of the easiest courses you can ever do. It's true. All right. So once you know these rules, then you can tackle. You had a question? I guess, as a scientist, you should be interested in the vice versa. So the more information you know about the system, the better the system can be. So if I know that this determines this, like if I know that item determines price, that's one kind of knowledge. Knowing that price determines item, that's another kind of knowledge. So if one holds or both holds, they do infer something about the type of information you have. I hope you understand. So it's about trying to understand the system you are working with. Right? As with maybe accounting or any other thing, you want to know what are the rules inside, right? If you go to a bank, you want to know, okay, can I move money from account A to account B? They say yes. Can I move, okay, so right now I think in Ghana, maybe you can move money from, can you think maybe from a dollar account to a CD account, but not CD account to dollar account? There are these strange rules going on in the banking system. Right? I think it was to prevent people from turning all their CDs to dollars in one step. So you can try it if you have a bank account to see if you can do that. Maybe the rules have changed. So if I'm wrong, please check now and see. But there used to be that rule for some time. But I don't know if it still holds that you can just move if you have two accounts, move from CD to dollar, dollar to CD. There are certain rules. Right? Or even across countries. I think across countries, you have to have a special, it's called a foreign exchange account. If it's not a foreign exchange account, they won't allow you to move the money. So you have to open a special account called, I spend too much time at banks these days. But these are some of the rules that occur. They'll tell you this is possible, this is not possible. And if you know, as a businessman, then you can plan your things ahead, right? So you know that, okay, if I want to receive payments from outside, maybe I should have this type of account because if they try, it will fail. Right? So knowing the rules helps. So for data as well, you should, as much as possible, you should be interested in what are all the rules that hold. It's possible. So the more data, so this is only a snippet of data, but the more data you have, the more information you can infer. But the other point is, if you have a sample of the data, this will happen a lot if you are working for somebody. You can ask, okay, can we give you some sample data, or you show us some sample data? Then when you look at it, you can ask further questions. I hope you understand. So maybe for this one, I'm saying, okay, that's item will determine price, and that's price will determine item. Maybe for that, their system that holds. Right. Let's take, so one way I see this is those companies which are doing membership, where maybe there's gold, platinum. For those ones, when someone makes a purchase, even if the telephonist asks you, how much did you pay? They should be able to know what package you sign on for. Like if you called maybe Vodafone and you tell them, they tell me my monthly bill is 100 Ghana. Then you have an idea, am I on home or basic? So there are some systems where those rules hold. There are some where it doesn't hold. Maybe if it is, let's say a shop, it's possible that two things are one seed. Right? So usually once you see something like this, then you can ask maybe it might even be your own company. You can discuss whether or not it's a rule that is always holding. Right? So are people cool? Okay. So let's look at the main issues the types of errors that can occur in a database, right? So already you can see you can insert data, you can update, you can also delete data, right? If you know that certain rules hold, right, like this one, if certain rules hold, then it's possible that any manipulation of the data, whether you're adding, removing, or updating, could introduce a violation, right? So, for example, I just hope that all right. So, for example, we're told, or well, we assumed that items should determine price, right? So it means that if, let's say, I tell someone to go and record a new company, and he goes in and enters price 3, right? That means that if I know that a certain rule holds, what you are doing is violating that rule, right? So this specific one, because I inserted, oh, come on. Oh, why did you do this? Okay. I think I have to learn more shortcuts. Nope, still not. No, it's not liking me. Okay, this is better. Because I inserted and it caused an anomaly, it means that what? It's an insertion anomaly. Right. So if you are trying to think of what anomalies can happen in a database, this is one of them, an insertion anomaly. Because you know a certain rule holds, but because you have inserted and violated the rule, you have caused an anomaly. Are people understanding this point? No. Okay, so we said that previously, item was supposed to determine price. Does this follow the same pattern? No. So it means that this is an insertion anomaly. Right. So all of them, whether insertion, update, those ones are the easy ones. The deletion we'll talk about very soon. But for insertion, that means that you've done some insert that is violating some functional dependency that we believed or were holding. So can someone give me another one? Not the same item price. What other rule did we have? Okay, so we also had supplier to CEO. So can someone propose an insertion that will cause an insertion anomaly for supplier to CEO? So for an insertion, that means you are giving me a new row. A new row. Give me a new row that will violate this. Okay. It's cereals, cereals, Ghana cereals, sorry. Okay. So this is a violation because what? We are expecting, or earlier we were assuming that anytime we have a supplier, it determines what? The CEO. And now there's a new row in there where the supplier, so this is the second one. To make this thing. Right. But this violation was due to supplier and CEO, right? Okay, so it seems everyone is cool on this one, right? Insertion anomaly. That means that if you check the functional dependencies before, check that they are holding. if someone does an insertion that violates a rule that you thought should be holding, that is an insertion anomaly. Right. But he was hinting at the next one. Question?
So this
functional dependencies.
Do you define it when you are creating the table? So because when you insert the value, if you insert the value, if you have not specified that this determines that, how will your SQL know that it's a functional insertion anomaly?
Okay, so what you have to do, so right now what we have is we have tables, right? This is just a sample table, very small table, and based on the rules that we think are holding, as we are doing insertions, we are picking errors. But there's also another issue, that is the design of the database as it is. If this is my table in my database, this means I have a poor design. I should have split it up properly so that any insertion or any deletion does not cause an anomaly. I hope you're understanding. So as it is now, it means that it's a bad design because certain inserts and updates are causing anomalies. Right? It's possible I can split this into tables enough so that when someone inserts new data, it shouldn't cause an anomaly. It's small enough that I think you can tell what equivalent tables I can use. I can still rearrange this, put them in different tables, spell out a foreign key, primary key, in such a way that any insertion or update or delete you do will not violate the holding functional dependency. Right? But this is just a slight toy problem, just to illustrate that having a poor design can lead to different types of anomalies. Right? So let's do the last part one, the update anomaly question. Ghana cereals to... Okay, so what we are saying is, another functional dependency is that previously, whenever we saw a supplier, we assume that there was a specific CEO for the supplier. So when we see Southgate, it's always going with Chen. When we see Annalisa, even though it's in 2 different countries, the CEO was always Schultz. Right? And for Ghana cereals, the CEO was Kwache. But now we are inserting some new data and we are realizing that for that one, we are causing an issue because it conflicts with the previous data we should have. Right? You will see this a lot maybe if you go out and do questionnaires and you're asking people questions. Like I can ask someone, okay, what country are you from? Someone say, I'm from Ghana. What's the capital of your country? Kumasi. Then you know, okay. And one person say, what's the capital of your country? Accra. What's the capital of your country? Lome. And you're like, So for that same country, you would expect that it should be consistent. That if you mention the country and you also ask the capital, it should follow. Right. You also see this in some, not other experiments, other questionnaires, where they are trying to test to see if what you are telling them is true. Right.
In that case, wouldn't it be a question the insertion statement is valid instead of the whole design?
It's the whole design. The insertion, if we redo this design, insertion should not be causing an issue. Insertion should not be causing an issue. Right. Okay, so this is insertion anomaly. The next one is what? Update anomaly. Now, if we make an update to this information, and update anomaly is the most common, just because people do ask, okay, some of them didn't come up today, but some people are using other dbms systems where things are not, I know you can turn off all the rules, or you can pick a dbms which doesn't enforce any rules. Some people do it, but that means that then your application has what? Checking that the things are correct. But the update anomaly is the most common, in that maybe I have designed a system, and I'm asking people to maybe enter an address, a house number, and also enter some GPS coordinates. Right. Now, if people start putting in their information and ask someone, go and make an update. So an update someone could go and make in, for example, even this, is they'll go and they are told there's a new CEO for Annalisa, who is now called Charles. Right. Yes. Hi, Prince Charles, perhaps. So there's a new CEO. But the person goes to update the database and only updates in one of the rules, or updates some and leaves some others. That's the thing. That means a good design should have what? Handled it in such a way that when you update in one place, you should have done for all. Right. So this is a problem. I just picked a problem, a small case that I'll highlight. But what I'm showing you here is that it's something that happens in real life. Because if someone makes a database, or I know that some people want to use other different database systems, right? They are there. There are some systems which, based on how they are designed, will not be enforcing or replicating the information or linking things properly. It's good. It's good to have. That means you don't have to worry about anytime someone inserts, you have to go and check. But then the problem becomes these types of things. Someone updates one place, forgets to update the other place. Right? Let's say, Ashesi, we are here, this course code has changed for this class. We update some students and we let some students out. That means that if we send the information to our auditors, they'll look through and say, well, the course code no more exists. Because some students have one course code, some people have a course code that is no more supposed to be in the system. Right? So if that happens, then you're having what? An update anomaly. Some things have been updated, some things have not, and it's what? Causing a conflict of the functional dependency. Right? So this is, sorry. Right. So that's the last part, one type. So is everyone cool? You've seen insertion anomaly, update anomaly. Right? That means that you have done an insertion and update. That is violating the rule that we thought you hold. If the person updated both things, made both things Charles, there's no more an anomaly. But so long as one of them is not and is causing a conflict, there is an anomaly. Right? So I know some people are saying they'll make their databases and they'll put in foreign keys. You realize that foreign keys is doing something like that. I hope you realized that when you define primary key, foreign key, and you link it, it makes sure that in the foreign key location, you cannot put something there that's not on that side. And that's really trying to solve some of these issues. Right? So having a design where you choose your primary key and foreign key carefully, you can help solve some of these. And of course, if you have a big table and you have many columns, you also have to watch for these. Right? So in your design, before you start creating all the tables, some of the questions you should ask yourself or ask the person who you are working for, or your client or your customer, or even your own people is, what determines what? Right? From this column, does it determine this column? This column, does it determine this column? Right? The last one, so this, please pay attention because this one always beats people sometimes, right? Is the deletion anomaly. Right. Right. So sometimes, actually, it can work for updates as well. So for some updates or some deletions, you will end up losing information about certain things entirely. It will be gone. Right. So for example, in this database, so let me do this. If I were to delete this row, sorry, I could even pick like this one, Sheng Limited, this one. If I delete it, we will lose information about the fact that we were some milk, we had milk, it will be totally gone. Right? We will also lose the fact that we had Sheng Limited. China, we don't lose information on the fact that there was some country called China. That one will still have it. Right? But that means that even for deletion, which is why, and you have seen this in your database as well, when you delete information in a relational database, often it's gone. There's no way back. Unless maybe you have some Boolean somewhere where you say true, false. Say, I intend to delete this, I don't intend to delete this. Some people use that approach. But often, the moment you say delete and you delete a row, it's gone. And so imagine if maybe you have done some survey, sent people around, they've collected all this information, put it into a database, and then you went to delete. And then once you deleted some things, the information is now gone. You don't have any way to get the information back. You've lost information about the item. Right? But you realize some things, if in a database, can still be used. So for example, a student can come to campus for one reason or another, says, I'm going abroad on holiday one whole semester. You will delete the person's information. When the person comes back, you have to reinsert. So if we deleted the row and we end up deleting so much information, then we have lost that student. We don't even have the fact that the person attended this campus. Right? So as much as possible, even for deletions, you also have to ask yourself, am I losing information? For updates can happen as well. For example, if I updated and maybe Sheng Limited, I used a different company name, I could also lose information about Sheng Limited. Right? So for deletion anomaly, usually it's the fact that we are losing some information that we would like to have. Right? So are people understanding the last one? It's kind of tricky, but I hope it's not. Deletion anomaly. So if I deleted this, so let's say this is deleted. Right now, if I ask you, oh, how many companies have we dealt with? You will give me a different answer. Right? If I ask you, okay, what products have we dealt with in our lifetime as a company? You will give me a different answer. Because what? Some core columns, information, is gone. So is everyone cool? Sharing is gone, right? There's no information about sharing. Meaning that if you had a system, so let's take Ashes right now, or the school as it is. Even though last year has passed, some people have graduated, they are no more allowed to log in. Some courses have gone. If you ask us questions, who took this course 2008, we should be able to answer. It shouldn't be that, because we are in a new semester and we have lost all that information. So your design has to be in such a way that even though things are changing, if the institution or organization cares about the information, even though they are deletion, so every semester here will change the year. And I think year to year people ask me, it's showing 2015, we are going to 2016. Yeah, the years are changing. But we are not losing information. Right? We are updating things, but we are not losing the information. Every year when you log in, you are seeing different lists of courses. But your previous courses are still there. Right? Even if, I know people won't believe it, but even if you are dropping courses, sometimes we'll say you drop on that date. We still can tell when things happened. Right? So it means if the institution cares about something and says, this information, I'm interested in it, and in your system, a deletion will totally wipe it out in an unintended way. Especially where, so unintended means that, I want to go and say, I'm no more interested in milk. This was my initial target. My initial target is I want to go and delete the milk. I don't want to deal with it anymore. But then when I am removing milk, I end up removing more things than I ever intended. Right? That means that there's a difference between intent and your consequences. When that happens, so for a deletion anomaly or an update anomaly, when you are intending to just lose some specific information, but you end up losing even much more than you wanted. So I said, I want to remove milk, but now, by removing milk, I'm also removing Sheng, and I'm even removing CEO Ahmed. That means there's no relationship in the system to show us that, we have any dealing with him. That means that I am what? Creating or courting or causing. Yeah, causing. Well, more or less courting, encouraging. Too many synonyms. A deletion anomaly.
I'm just wondering, do you really delete from a database? Because sometimes we are advised that if you have a user, you can disable or enable user instead of just copy.
Okay, so usually it depends on how much information you want to keep. The ones that you really want to keep, even though someone will say delete it, you may not delete it, you may just disable or hide it. Right? But there's some information that someone will say, I really don't want to have this. Else the database will grow just increment, forever and ever. So usually, even things as logs, where someone keeps log data, now and then periodically, we may sift through and throw out the ones you are not interested in. Right? So the ones that you are interested in as a company, you can keep. What some people will do is they'll back it up to some, I think you've heard big data. Big data, you keep hearing big data. Part of the issue with big data was, for some companies, there's a lot of information going on. So let's say on campus, we could go crazy and say everything you click. So every click, actually, I think, the servers know. As you request pages, they know. Every web server, even your Apache, the one you're running on your machine. Anytime someone clicks, but the question is, do we want to keep every single click? No, it adds up very quickly. It adds up. So if every...
Isn't that like a breach of privacy if you keep records of what students are clicking and not clicking?
No, it's not a breach of privacy. So here's the thing, every single thing, even your Windows, when you log into Windows and you log out, Windows knows you logged in and you logged out. So,
Windows won't bring the information, but you guys are putting down information. And I feel like there is a breach, like almost as if you guys...
okay. So what's going to happen is, at the end of maybe every 2 or 3 weeks, what will happen is if nothing is interesting, just wipe that, because it's not something we're using for our operations. But another company, let's say Amazon, I'm not saying Amazon is doing illegal breach or whatever, but some companies will look at it and say, this is information now we can mine to say, okay, if people visit this page, then they are likely to visit this page as well. Or if someone searches this thing, he also search this one as well. So some people may think, okay, this one I don't want to keep it, but some people also say this is the core of my business. Right? But actually knowing what people click, so Ashesi has things like Ashesi Institutional Repository, where articles are there. We are interested and we are curious to know if people are clicking on our articles? It's a good question. Even if we don't know the specific person, we still like to know at the end of the day that, oh, okay, this article is the most clicked page. Even on Courseware, we would want to know which pages are people visiting the most, which courses do people like the most, or which courses do people go online the most to submit assignments for. Those are valid questions. Because if a course is there, nobody has ever been in there the whole semester. There's something going on. So it's an interesting question for us, but maybe not for the whole, maybe for 10, 20 years, no. But maybe in that week, we are curious to know, is there a course where nobody visited? It's a valid question. If nobody visited, what's going on? Right? Or even if logging in, a student hasn't logged in for 1 month. Something we are curious, why haven't you logged in the whole month? No, you have not logged in. That means you don't have any assignments. You don't read anything. You don't, I don't know. It's interesting. Right. So information usually depends on the organization, what they want to keep. Okay, so is everyone okay with deletion, updates, and insertion anomaly? Right. So remember, the deletion anomaly occurs when you are intending to delete one thing, like I want to take out milk, and you end up deleting other information permanently. So, sorry. The consequence, that's also gone. Right. So if you delete one, or say this can actually happen to you. Sometimes there's a query you can do delete from, and you want to delete something in particular. But then when you delete it, some extra information is deleted. That's your deletion anomaly. So now, based on this, we have heard of this thing called primary key, foreign key, and so on. But even just based on this little one, we can write out the rules that we believe hold for this system. So, let me make a copy of this. Duplicate. And there was duplicate. Okay, move or copy.
If you get a question on this, I suppose you just write a
Yeah, so I could give you a table and ask you what are the functional dependencies. And so if you give me a functional dependency, I'll go and look at the table and see if what you told me is true. But not just me. I mean, if you are going to work on a project and you are giving some data, usually that's what you have to do. You have to look through and say, oh, is it true that this always leads to? It's a valid question. Right. So let me just clean this out a little bit. And, okay, that was... okay, so I've cleaned this up. Now I have... no errors. Well, at least the rules that I had initially are still holding, right? Right. So that means that when we are going to do a design, usually we will try and list out all the functional dependencies that we have in the table we are looking at. Right. So some of the ones we picked out was that item was given as price. That price was given as item. Supplier was given as the CEO. Was CEO given as supplier? Oh wait, this one became Charles. Okay, so does CEO also give as supplier? Giving Chen, am I always getting Southgate? Giving Buhari, Mecca, Charles, Bika, Ahmed, Chen, Anand. Okay. Is there any other thing we are missing? We are fine. Okay, so that means that if we look at any table, so should start to hint at us as to what a primary key could be, right? So currently when people say primary key, they just say, okay, primary key, it's something that identifies, and people even want to add in numbers to try and make everything unique. But if we know what the functional dependencies are, we can actually determine what should be the primary key. Right? Can anyone guess what the primary key would be if I know the functional dependency? What should be the rule for finding a primary key? Or a key?
So then, let's say if A functionally depends, then A should be the primary key.
That's it. So the thing that provides all the other things in the table is actually the primary key. So in this one, someone could go and pick. So sometimes there isn't going to be just one key. There may be multiple keys. Right. So someone can try and pick up some candidates. So candidates for key. That means those items that can determine everything else. So there'll be some candidates. So for example, if I picked item and, okay, maybe supplier. Okay. Will item and supplier get me everything? Maybe not. But let's see. For this one, item can get me the price, right? So two things are covered. From item, I can get the price. Supplier can get me CEO. So the only thing left is the country.
So the supplier is like a code for a supplier. Let's say two suppliers have the same thing.
Right now, I just mean if you see Analisa, it's the same Analisa. I didn't use any numbers, just so all of us can follow. Right. So,
if you are putting into the database and you are basing on what we have to set it as item code or supplier code.
okay, so what I mean here is, if you know about the functional dependencies, you can actually write a design that better captures the rules. So remember that just adding, I know some people just always want to add an auto increment. That's beautiful, it's always nice. I see a table, add auto increment, ID. But that doesn't mean that your design is very good. It doesn't mean that just because we add an ID, the design is good. The better question is, what are the functional dependencies? Because once we know the functional dependencies, we know the rules, right? And then once we know the rules, we can determine, and that's why in some of the questions, like there was a movie that was identified by the title and the year. Because going through, they know, okay, year alone doesn't do it, title alone doesn't do it. So in this case, I'm almost there, but I need one more thing. As far as this specific table is concerned, item and supplier is only giving me 4 of the rules, right? So from item I can get the price. From supplier, I can get the CU. But country is still left out. So item and supplier currently is not enough to be my primary key. If I didn't have this column, if I didn't have this column, I'll be good to go. That means that I'm able to, using just my functional dependencies, determine what the key should be. So the last thing is, so I hope you understand the question. If I can use just my functional dependencies to determine the core columns that are needed, that can be my key. But sometimes you have a case where there's, like this one currently will work. But if I had an extra column, for this table, this is not enough. That means that what? I will have to add the country column. Right. So it means country determines, so that's called a trivial functional dependency. Trivial. So if I ask you functional dependency, so someone could have told me Chen determines Chen. It's a valid functional dependency. Or student ID determines student ID. Valid. But it's what? It's trivial. Right. It's just like, okay, I'm trying to find one where maybe some things are trivial. Yeah, trying to find. I have to think. I have to try and find more. Sorry, my brain is all database today. So trivial is just. I'm trying to find another trivial case. Right. Another trivial case. But in database design, when someone says a trivial functional dependency, it means that it's a functional dependency where you don't really need any special knowledge of the database. Right. So if you give me any table, I can just say, oh, SID determines SID. It's trivial. I hope you understand the point. It is a valid, it holds. Right. So if I can list millions of such dependencies, I can say, oh, president name determines president name. Trivial. There's no extra thinking to decide that. Mouse determines mouse. True. Trivial. It's common. The same thing determines itself. So anytime you have something like that, or someone can try and be a little more sneaky, where they'll say item and price determines price. That's also what? It's trivial. So if I do, so note that currently we have been doing a lot of this, but I can also come up with, because item determines price, I can also say item and supplier determines price. That's trivial. I already knew the first one held, and I'm just adding more things to try and make myself look very, very smart and excellent. A different column.
Exactly. Let's say like the item as a supplier actually holds.
Okay, so you realize that the ones that are not trivial, like item to price, it's not the same thing all the way through. It changes. The item name changes, the price name, okay, at least the item name seems to be changing along. So it means that it requires some thinking to get to that conclusion. But some of them, like item price to price, it's kind of trivial because we know that item and price are together. And you're telling me that item and price determine price. That's like, there's no thinking involved. It's almost like you're Sherlock Holmes and you get to there and you're like, I know who was in the room, or I know who is in the room. I am in the room, you are in the room. Everyone will be like, Sherlock, I think there's something wrong with you. I mean, you expect that Sherlock Holmes would enter the room and say something that nobody can, can easily tell. Like, oh, I can smell perfume, therefore she's hiding behind the cloth. I mean, that's better than you are in the room, I'm in the room. We are all in the room. It doesn't, I hope people understand. That's trivial. So it means that if we learn our functional dependencies, or we can list them out, we can determine really what is the primary key. Because the functional dependency, as she said, will lead to all the columns in the table. Right? And the ones that don't. So in this case, for example, item and supplier can lead to everything, but country was hanging. And that means a country can determine country, and we can just say, let's add country to the list of things that we can use. Right? Now, please note that it doesn't mean that for every table there's only one key. It's possible to have multiple keys. Right? The term primary key, I think what happened was people were designing database, were coming with candidate keys and primary keys. But usually, what people get at the front end is the primary key. So people forgot that the information about the primary key came from somewhere else. But it came from the fact that someone who designed a table spent time, if really you did spend the time, to go through all the possible candidates, discuss with the company. So usually to try and pick which of the candidate keys. So what other key can I pick apart from item, supplier, country? What else can I use as a key? There's supposed to be, I think, you can come up with a few more. Okay, so I can do item, CEO, and country, right? Because from item, I can get to price. From CEO, I can get to supplier. And country is the last one. So you can come up with more and more keys. But eventually, you have to pick one. And that's where that term came from. The term that we all know these days and love. That everybody says just like that. Primary key, primary key. And what's the primary key? But there was the concept of candidate key. So it's almost like elections. There are many candidates for keys, of which you pick one. I hope people are understanding. Right? There can only be one. It's not a Highlander or something. I don't know, but there can only be one. So eventually, the one that you have to specify will be your primary key. I hope people are cool. Okay, what I know. So where did I lose you? The candidates and the primary. Okay, so that part is very important, right? Is that in any design, when you go out in the field and you design, you have many potential keys that you pick, right? But in something like a MySQL, what you realize is it will ask you to pick one key, and that will be your primary key, right? And that primary key is what usually the company will use in identifying people, right? Or identifying the item. So, for example, on campus, we could have used social security number. I mean, I think admissions has that information. They could have used that one. They could have used maybe a combination of your birth date and age. I think that seems to work well as well. So there are a few things that they can put together to identify you. But throughout, it seems that either student ID or username seems to be dominating. I think student ID first. Because usually we create that one even before the IT department adds on the usernames. So there's something that we use, even though there are many candidates, to identify the role. The one that we pick becomes the primary key. So they almost go into an election phase. You pick all the candidates. Those are all the options. And the one that can what? Or that the company wants to use of all the candidates becomes the primary. Right? But for the other ones, it does also mean that the other ones are also unique. I know we don't want to think too far, but let's think about it. If anything is a key, then it must what? Also be unique. So that means this combination of item supply country is expected to be unique. Combination of item CO country, that is what a key does for us. So knowing the others also gives us some information about the system. So even if I know, okay, according to this system, we are not supposed to have two students with the same username. We check and enforce it. When you try and insert, it will check. Does this username exist? If it does, block. Because we don't want to have two people logging in, registering for, I don't know how that will happen, but it's something I can't get my mind around, so we don't allow it. How can two people have the same username? How can two people have the same student ID? Right. So those are some things that, yes, if I were just doing the design without worrying about, so those who just want to do primary key, you do the primary key, student ID, fine. But what about username? It is also one of the potential keys that we could have had. So in our design, we make sure that it's unique, so that even when people are adding data, we also check on the other keys. So it's good to go through this exercise to identify what are all your keys. Question and then question. So
What are the advantages of doing this? Especially in this case where we have three columns becoming the primary key. What are the advantages of this over creating, let's say, an ID?
So that's my question for you. Now today I've taught you about functional dependencies. Why would you want to do this over just creating an ID? Is it just the convenience? If I just did that convenient one ID, like in this case, I just put ID on the side, would I still be able to enforce some of my rules? But you have to do some extra work, right? Yeah. So the thing is, there are many ways to do something, but at the very least, I expect that you can do the formal way. Right. So, yeah, you can add constraints and enforce that certain things are unique. That's also fine, right? But in design, what I usually will ask, when I say use the functional key, find the primary key, I expect that any student of mine can go through this activity. Can go through and say, oh, I know I've determined all the functional dependencies. These are the primary keys. Or, sorry, this is the primary key. These are the candidates. And this is the one I'm picking for primary. So I mean, when you have multiple candidates, then the choice just becomes pick one that you feel is convenient. Right. Okay, so the other thing that I'll add for primary, when someone says something is, so I'll say key versus, so this is just technical talk from the text, or something that, well, it's almost like, I'm sure the accountants have a lot of terms as well. I mean, I've heard of ledger and something balanced, ledger balance, actual balance. They have their terms. Let's also have some terms that we can use. Right? So this is just two terms. You see it in the functional dependency chapter. When they say key, right? Key just means anything that can be used to uniquely identify a row. But when they say a candidate key, it means that the set of things must be minimal. Minimal meaning that you can't remove one and still have it be the key. So, for example, item CEO country. If I remove CEO, it is no more what? Going to be a key. Right? That means that the set of things I have is the primary, or is a candidate key. Right? So all the candidates must be minimal. It must be. So if I ask you, what is a key? So please don't do this. When I ask you, okay, you can't, but if I ask you, give me some candidate keys, and you go and say, okay, item, price, supplier, CEO, country. Yes, you can in your database design. Primary key is always all the things. That can work because it will identify. But it's not really a good definition for primary key. Because for a candidate key, first of all, you have to ask yourself, what is the minimal set of things which you can get when you do the functional dependencies? Figure out what are the minimal set of things that I can use to determine all the columns in the table. All those people. So, item, supplier, country. That is minimal. I can't remove, minimal meaning what? I can't remove something and it will still work to identify the rows. This as well, item, CEO, country. I can't remove item. If I remove item, CEO and country may not work alone. There could be repetitions. If I leave item CEO, there could be repetitions. So I have to make it such that I'm left with the smallest number of things that can determine everything else.
So are you saying
Okay, so let's go through. A key, let's start with a key. Key is the biggest one. Key means anything at all that can uniquely identify a row. Anything at all. So for example of key, so let me see. My key could be item, supplier, combined country, combined price. Okay, so that's an example of a key. That means I have even more things than I need. So if I asked you, so if you were asked, oh, please give me a key for this table. Trivially, so I say trivially, you could just list all the columns, and that would be a key. Because all the columns it represents the whole thing, right? Because it's unique. All the columns, I picked everything. There's your key. But that doesn't show design or any thinking, right? So keys are there. You can have many keys. The ones that we are usually interested in for design purposes are the candidate keys. That's those keys. That's the fewest number of things. Those things that are so few that they will identify all the rows, all the items in a row. So if, for example, in your student row, if I pick student ID, from student ID, I should be able to infer everything about you. Student ID, from student ID, I can tell the nationality. Student ID, I can tell the date of birth. Student ID, I should be able to tell the name. Student ID, I should be able to tell the age. So that single, even if I pick an auto increment and I pick that one, it should determine all the other things. That means that it is really functioning as a candidate key. And if I pick that one as my primary key, it means that's the one that the database will try and use when pulling information.
It goes from key to
Candidate to primary, yes. So it becomes more and more constrained and more specific. So from key to candidate key to... So key is the biggest. Anything that identifies the row is a key. And they are trivial keys. A trivial key is what? List all my columns for me. I didn't think about it. Right? Just as trivial functional dependency is ID determines ID. You didn't have to think. Right? But then, as far as design, you start with, yes, you have your keys, but you have to ask questions till you find your functional dependencies. And for that one, you may have to talk with your client or something. You have to ask, okay, does it mean that every time I see this name, it should go with this? Then you see that you are refining your understanding of the system. Once you have all the functional dependencies, and sometimes you can get functional dependencies and realize that what the person said was the key is not the key. I hope you understand. Because if someone comes up and says, oh yeah, we are using student ID as a primary key in our table, and you go through and you realize, you know what, the student IDs aren't even unique. Or something else is determining student ID, and sometimes it's determining what different things are overlapping. You're like, oh, you know what you thought was supposed to be the key is not the key. So as much as possible, we do like to go through this exercise. Seems boring, and I know for a lot of people, their databases are so small. The ones you are doing are very small, so you're not really, everyone has an idea of what the table should be, what the relation should be. But we need to have some strong formal knowledge, techniques that we can use in case the things are becoming many. We don't understand everything, but if we use logic, so this is about logic. If you know A determines B, just that base logic, you can do a good design. I hope everyone is on board. No, yes, maybe so. Okay, so today I will end it here. I won't add any more to it. What we'll do next time is we'll look at the different ways we can use these functional dependencies. So you can read on it, read ahead. First normal form, second normal form, third normal form. Normalization. Normalization is what we are coming to do in the next class. So on Monday, we are going to do normalization. I am going to set up groups so that for this Friday as well, you do another design on this Friday. So you have done one group work, which is due, I think, today, right? Okay. So coming up this Friday, I'll put up some questions. You have chosen your databases. For this coming Friday, I will pick some descriptions on databases and ask you to design for me. So it will be similar to what you have. So maybe I'll say, oh, there's a shop, there's this and this and this. And you will do your design, and then you upload. Our class there are some conflicts at 8 a.m. Are you sure? But the fourth is the one that the registrar told us to use. So you have FD in the morning at 8. Okay, let me stop this.